now we continue inside the LIFE ABATE consortium, now with Marcel Macarulla. He is Associate Professor at the Polytechnic University of Catalonia, belonging to the Construction Research and Innovation Group named GRIC, expert in the integration of greenhouses with buildings of various typologies to investigate environmental assessment and circularity synergies, with a focus on energy optimization, indoor air comfort, and AAK modeling. Head of EUGW25, a living lab that integrates a greenhouse into a building's ventilation system to explore real case indoor air modeling and energy efficiency.
Okay, thank you, Gloria, for your introduction. I'm sorry for this small issue. As Gloria mentioned, I am Marcel Macarulla, and my presentation is Expected Impact Life ABATE, Reductions of Emissions, Energy Efficiency, and Cost Savings. And this is the content of my presentation. I will explain you the current configurations. I will not go in deep because my colleagues explain it very well. I will just explain the flux of energy, water, and emissions. Then I will explain you the same for the proposed configurations. I will explain you how we did the LCA modeling and the preliminary results in terms of LCA energy costs and energy efficiency. Okay, and finally I will present you the preliminary conclusions and when we plan to obtain the final results. Okay, the first configuration is in the eco park. We have a regenerative thermal oxidation. Okay, that is treating all the air that is inside the eco park. And how is it working is through the use of natural gas and electricity to move the air. What we are doing is to burn the pollutants and then avoid these odors. Okay. This is the last DSS biofilter that my colleague just explained it. I will not explain it again. And here what we are using is natural gas electric input, water input, and fungicides. Okay, and then the electricity input. Then which are the solutions that we propose? The idea here is to take the air from our installations, put it in a roto concentration, just to treat less air than we are doing right now, and then treat with a regenerative thermal oxidation. Okay, and then put it in the greenhouse. Here the idea is that the regenerative thermal oxidation is using or is sending the concentration is using recovering waste heat from the RTO, and the greenhouse is recovering the waste heat and also the CO2 of the whole system. Okay. And then here is our system, is a pilot plan. Okay. The idea is we will treat 20,000, 2,000 will go through the RTO and then to the greenhouse, and then we have 80,000 that is going to the exterior. This is a pilot plan. Then to avoid odors, we will put again this just to be sure that the roto concentration is gathering or is catching all the odors. We are putting this air inside our installations just to be sure that the odors are completely removed. In the case of the biofilter, this is the scenario. Okay, the idea is the same. With the roto concentration, we treat less air, and then with electricity, water, and silicone oil, what we are doing is to treat the air and then put it inside the greenhouse. Here, the idea is to recover the waste heat in winter and to recover the CO2. And again, what we are doing here is to be sure that we are not putting volatile components in the air. We are reusing we are putting the air that it's going outside the roto concentration inside the facility again to be sure that we are not throwing odors to the external part of the building. Then the LCA modeling, these are the configurations that we analyzed, the eco park plus the RTO, the last days with the biofilter, and then the reto concentration, the RTO, and the greenhouse, and the reto concentration with the two-phase biotrickling and the greenhouse. Here, what you have to notice is that in the eco park we didn't put the greenhouse, and in Las Dehesas we didn't put the greenhouse, and as you will see, the results are a little bit strange. But the point is that here is a pilot, and probably here we should plan which is a typical greenhouse that we can reuse. Okay, then I will explain you how we did this extrapolation. We focused on the operational phase of the technologies, okay, mainly on the energy consumption and the rest of the things. And we considered a continuous operation between 24 hours a day and an expected lifetime of 25 years. And we declared the functional unit is 1 meter normalized meter cubed per hour of treated gas. But you will see in my last slide that this is a little bit tricky, because at the end we have two functional units. We are treating the air, but at the same time we are producing food or crops, and this is something that we have to analyze in the future. But right now, without knowing which is the crop we have to use, and if this crop can be consumed or not, the analysis changes. Okay. Then the LCA, we used the software Sima Pro, the database EcoInvent, and this method, and the indicators that we used are these ones. Okay, climate change, ozone depletion, ionizing radiation, photochemical ozone formation, particulate matter, human toxicity for non-cancer and cancer, acidification, eutrophication, fresh water, eutrophication marine, eutrophication terrestrial module, eutrophication terrestrial, ecotoxicity, fresh water, land use, water use, resource use fossils, and resource use minerals and metals. Okay. These are the results with reference to the eco-park. As you will see, the best solution here is the Las Dehesas. However, we are not considering, as I mentioned before, the greenhouse. Okay, if we put the greenhouse, we will see an improvement. However, here we are comparing only the two systems, like the two options, like we propose. We have a problem of scalability, because we don't know exactly which are the costs of our system if they work on in a bigger system. Right now the calculus are done, the RTO, the Eco Park, and Las Dehesas with real data, and these two are done with the pilot plan. Then this is not helping us to obtain good results. As you see, the pilot plan has no discussion, better impact than Eco Park 3. However, in Las Dehesas, here the problem of scale is penalizing us, and for this reason we have this increase. But we expect, as my colleagues explained before, that when we can normalize the values or obtain better estimations of which are the calculus that the real data that we consume here, we can reduce the climate change impact and the rest of the impacts. Okay. Then, if we talk about energy efficiency, you see here that these are the kilowatts hour per normalized meter cubic. Okay, and these are for the old configurations. However, to compare, we need to add a greenhouse to the baseline scenarios, and we considered that in the Mediterranean area, if you want to hit a greenhouse, okay, you need at least 381 kilowatts hour per square meter per year. Okay, then if we want to do an estimation of the energy savings of the whole system, okay, we have to consider the Eco Park with the greenhouse, Las Dehesas with the greenhouse, and then our systems with the greenhouse. If you see here, we are recovering waste into the waste generated, the waste heat generated in Eco Park and Las Dehesas, and this helps us to avoid the energy consumption on this potential greenhouse that is a 7,000 greenhouse, okay, for a treated this volume of air treated, okay. If you see here, the reduction in terms of energy is very high. If we talk about the cost savings, here it's a matter of which is the energy that you use. If you use more electricity, the costs are higher than if you are using gas. I took these two costs from the last report from Red Eléctrica, that they say that in Spain the average cost of an industry is 0.10 euros per kilowatt, and the gas is 0.04 euros per kilowatt. Okay, but of course this cost should be taken carefully, because it depends on market situation. Okay, and here the actions that we are doing also is recovering the waste heat in the greenhouse. Okay. Then, if we talk about the preliminary conclusions, first of all, we have to say that the estimations are still preliminary, and the results can vary along the project. You have to know or to consider that the estimations of Las Dehesas and Ecopark was very easy to do, because we have all the information from our colleagues. All of them provided us all operational data that we need, and then this data is there is no discussion. However, for the operational phase however, for our pilot plan, we have a small equipment, and we have the problem of scalability, and this is penalizing our estimations, but we have to find a way to compensate that. Regarding at this stage, we only considered the operational phase, because we don't know which is the impact of building a new regenerative thermal oxidation plant or a new biofilter. Okay, but this is something that we have to do in the next steps of the project. Here we see that the Las Dehesas is the one that has low impacts in all categories, but here the problem is which are the viable crops that you can grow, because if you can grow crops, then you have 2 functional units, and then the results will be much better. Okay. Then Abate solutions ensure a reduction of all impacts in all categories, especially in climate change. And again, and this is something that I want to explain and to remark, is that the reductions are expected to be even more significant once the project is scaled up, and when we know if we can reuse the crops or that we have inside, if we can eat the crops that are inside the greenhouse or not. Another thing that it's important of the Abate solutions is that they need less space. They are more space efficient, and we have a low capex. Okay, and then another interesting thing of this system of the system proposed is that it's viable to inject CO2 in greenhouse. Right now, here is in Spain, it's not usual to inject CO2. We know that in other countries like Holland, for example, they are injecting CO2 in technified greenhouses, but in Spain is not a common practice. Then if we can reuse this CO2, or we can put this CO2, then we can reuse the food and plants that we grow inside the greenhouse. Then we will have to deal with these 2 functional units, the treated air and the food plants and production. Okay, the food plant production. Then I think that here is the most interesting thing is when we will have final results. With the project started on the 16th of October on 2023. Right now we have the baseline indicators establishing a continuous monitoring ongoing. Okay, and the idea of the initial plan was in month 46, that this means more or less in October 2027, or this is the end of the project, but in September or August, have the LCA and the LCC completed. However, we had some problems during the implementation, and probably we asked for an extension of the project, then this date will be modified. And Gloria, I tried to be quick just to recover the time that I lost during my connection, but I think that I achieved the objective. And thank you very much. And here you have my contact details, and if you have doubts, you can put it on the chat, or I think, Gloria, we have at the end of the session open questions, right?
Thank you, Marcel, for keeping the timing, although the incident.
With the support of the European Union's LIFE program.